In this lesson, we are going to do 10.2, graphing y equals ax squared plus bx plus c. If you'll notice in the title of your notes, there is now the bx that is there. Yesterday's lesson 10.1, the bx was not there, and we looked to see how the a stretched, shrunk, or reflected the parabola, and how the c translated the parabola up or down. So today we're going to put everything together and we're going to see the properties of the quadratic function. So the first thing we're going to do is we're going to fill out the box at the top. And it says that the graph of y equals ax squared plus bx plus c is a parabola that. And it does these 5 things, and you can see it over here. So the first thing you'll know, and we kind of did this yesterday, is that the parabola will open up if a is greater than 0, and it opens down, which we know as a reflection, if a is less than 0. Now this parabola is opening up because it is positive a. It is narrower than the graph of y equals x squared, which we know is our parent, if the absolute value of a is greater than 1, and wider, which we know as a shrink, if a is less than 1. Now, this is probably the most important thing of the lesson today, is the axis of symmetry. Yesterday, the axis of symmetry went through the origin every time, but today that will not be the case. So we have a formula to find that axis of symmetry, which is this dotted line right here. Remember, it's the imaginary line that cuts the parabola in half. Now, the formula is negative b over 2a. And notice that I'm going to get the b from the equation and the a from the equation. And you will also notice that it is an equation, so that will make it a vertical line. Now, the vertex will also change today because the parabola will move over side to side. So the vertex has an x-coordinate of the same thing, negative b over 2a. Because think about it, if the parabola has an axis of symmetry that cuts us in two, wouldn't the vertex be through that axis of symmetry? Now, another interesting note is yesterday C moved the graph up and down, but when you throw the b in there, it's actually the y-intercept. So it has a y-intercept of c, so that the point 0c is on the parabola, and it is right there. So today it's not going to be as easy as yesterday because we have to factor in that b. So today we're just going to look at the steps to graph these. And there's 3 steps to graph it. The first thing you're going to do is you're going to have to find the vertex. That is the most important task. So how? How do you find the vertex? Well, you're going to use negative b over 2a. And remember, that's going to give you your x-coordinate. The second step will be a t-table. And the t-table, of course, you know how to do, but you want to make the t-table with your vertex in the middle. Because remember, the vertex will always be in the middle. And then the third thing you're going to do, once you get the t-table constructed, you will plot and graph your parabola. Now, notice vertex in bold capital letters. That is the most important thing today. So I'm just going to do one of these with you. I'm going to let you do the rest. But steps say find the vertex first. So I have a parabola. It is in standard form. And I know a is negative 1 because it's negative here. I know b is positive 4. And I know c is negative 1. So what I will do is the first thing I will find my vertex in my axis of symmetry. So I will say x equals negative b, which will be negative 4, over 2 times a. And that's going to give me negative 4 over negative 2, which is going to give me 2. Now that 2, x equals 2, is my axis of symmetry and my x-coordinate of my parabola. So just for reference, I am going to go and I'm going to go ahead and draw my axis of symmetry line in so I can see. Now, the next thing we're going to do, we're going to make our t-table, and remember 2 is going to go in the middle. Well, in order to complete my table, I know I have a 3, a 4, so 2, 3, 4, and then on this side I will have 0 and 1. So notice how it's in order, and notice that this right here will be my vertex. Now, at this point, you would use your calculator to generate your t-table, and you could use the table function on your calculator, or you could just simply plug it in. So one thing that I always like to do is I always like to start with my vertex. So I look at my original problem, and I have negative x squared. So I'm going to go 2 squared plus 4 times 2 minus 1. So that just generated a 3. So I'm going to put that in my table. And I'm going to go ahead and I'm going to plot that. So 1, 2, 1, 2, 3. Now I also look back up here and notice, oh, it's negative. So my parabola will open down. And my c is negative 1. So I expect that to be on my y-axis. So let's see if that happens. So I'm going to scroll up. I am now going to replace the 2 with 1. And I'm just using the key feature on my calculator. We'll change that to a 1, and I get a 2. Now remember that your table should always be symmetric. So now when I put in a 3 in place of x, I better get the same thing, and I do. I get a 2. So now I'm going to do a 0. So I'm going to go over here and change this one to a 0. And I'm going to change this one to a 0. And what do you know? A negative 1 appeared. And just to prove it to you, because I always like to make sure that it's working and that it's symmetric, I'm going to type in the 4, and you will also see I get a negative 1. So I'm going to go 2, 3, got it. 1, 2, 3, 2, 0, negative 1. Now notice that's my y-intercept, and 4, negative 1, and there is my parabola. So now I'm going to go, we'll draw it, and that's it. So a few changes from yesterday. For one, it's not starting through the origin. We now have a B there, and the B will change it. Now, to complete your notes, pause this video and complete 2, 3, and 4. Okay, go ahead and check your answers. You can see my tables, you can see my vertex, and if you have any questions, make sure that you see me tomorrow. Okay, now let's flip it over. And on the back, it's got minimum and maximum values. And if you think about it, where is the lowest and highest point on your graph? We talked about this yesterday. It's the vertex. So we're going to draw arrows here. You also know how to find that because it is your vertex. So remember, if A is above 0, that means A is positive. And remember our smiley face yesterday. So that's a parabola that opens up. And if you'll notice, the lowest point will be your vertex. And it'll be an ordered pair. But Y will actually be the actual height of something. Okay? And this right here is what we call the minimum, because it's the lowest point on the graph. Now, opposite of that is when A is less than 0, it will be a negative. Therefore, the parabola will open upside down and reflect. And once again, that right there will be an ordered pair, and that is the maximum on the graph. Now, the word problems will now start asking you how high something is, how low something is, and you have to know, oh, I'm actually just finding my vertex. So 5, 6, and 7 deal with the fact of can you actually figure out what they are asking. So 5 just says tell whether the function 5x squared minus 20x plus 17 has a minimum value or a maximum, then find it. So since 5 is positive, we know the parabola will be this situation, so we know it'll have a minimum. So I'm going to circle that. And then to find that, I would do negative b over 2a to find my x. So negative 20 over 2 times a will produce a 20 over 10, which produces a 2. So that's half my ordered pair, but how do I find y? Well, in order to find y, I'm going to plug it back into my calculator. So I've got 5 times 2, and then I've got minus 20 times 2, and then I have plus 17. And that gives me a negative 13. But I'm going to check my math on that because I just noticed I did not put my square on my 2, so that is not the correct answer. So we're going to go back and we're going to change that to a square, and now that's more like it. So I get the negative 3. But that's not the question, okay? It says find the minimum or maximum value. So it would actually be the negative 3 is the lowest point on the graph. Now, number 6 deals with the formula, and it says what's the maximum height of the ball. So what I would like for you to do next is to find your vertex, okay? And then plug that back in to find y, and then see if you can figure out the answer. So pause the video, work that problem out. Now, when you did your vertex, you should have came out with 7.5 and 34.75. Now, kind of picture this to see what's going on. Okay, the ball is tossed. You're asked for the highest point here. Well, at 7.5 seconds, it was there, but it was up at 34.75 feet. And now the last problem deals with the suspension bridge. This one happens to be in Michigan. And you have this equation here. Notice how stretched out the graph is. Notice it's positive, so it's going up. And it's wanting you to find the height of the cable above the water. So you're actually looking for that vertex right there. So pause the video, use your calculator, and see if you can come out with the vertex. Okay? When you do negative b over 2a, you should have got 1910. That's actually right here. So 500, 1,000, 1,500, 1,900, and 196 was your vertex. Therefore, or so, it's 196 feet above the water. Now, if you have any questions about this lesson, please feel free to ask me tomorrow in class or during flex time.